All right, thanks everybody for coming. I'm going to talk about oneAPI for about the next 20 minutes. And what this is a single programming model to cross architectures, so across CPU and a variety of accelerator architectures. The problem out there is, while there's a kind of an explosion of different accelerator architectures in addition to CPUs, the challenge is that historically each one of those architectures has required pretty much a separate development flow. A separate language, separate libraries, separate analysis tools. So it means you can't really reuse much of your code or leverage much of your experience moving between architectures. Kind of introduces a lot of friction and headache for developers. So the answer we're proposing for that is oneAPI, and it's really two parts. It's an industry initiative, so we want this to be more than just an Intel thing. So this is all standards-based, open specs, et cetera. I'll talk a little bit more about how we're setting that up. Then a set of Intel products, software development tool products that implement that specification. And it includes a unified language, data per LC++, that we'll dig into a little more. This is, native high-level language performance. There's no managed runtime or anything like Java, et cetera. It's all performance programming, close to the hardware. I mentioned based on industry standards and open specs in order to get the maximum chance for ecosystem to contribute and participate. And an important thing to note is this is in addition to the existing HPC programming methods and languages. So Fortran, OpenMP, MPI, all those good things Intel's going to continue to support strongly and extend to our GPU accelerators. But we just think a kernel-based programming language like data per LC++ will be valuable and preferred by some developers. So let's talk a little bit about that language. Let me talk about this first. The spec is really a combination of all these things in the green box. So we've got the data per LC++ language, we've got a set of libraries, and then we've got a low-level hardware interface we refer to as level 0. That won't be used by most developers. It's more for tool developers or other hardware companies that want to present a oneAPI compatible hardware interface. For most folks, it'll be the data per LC++ language and the libraries that they'll be most interested in. So let's talk about the language. The idea of this is provide a single language so that people can reuse their code. But we expect that, as today, people are going to need to tune to each architecture to some degree to get best performance. So while there'll be some code reuse, there'll be some architecture-specific tuning as well. And the whole idea here is to have a cross-vendor, cross-architecture language rather than individual ones for specific vendors. You can see over here that really data per LC++ starts off with a C++ base. It's all legal C++. And then we're working with the Kronos group that's been developing this SYCL specification, which really includes a lot of good data parallelism and heterogeneous programming constructs designed to work across architectures. Now, because this spec is a bit immature, there are some gaps in it, and so there are some extensions that we're adding to really beef this up. One example is unified shared memory that wasn't in SYCL yet, very valuable, so that's been added to data per LC++, and it'll be in the next major revision of SYCL as well. So while we're adding some extensions, our intent is not for any of these to be proprietary. We're trying to offer them all up to SYCL, as well as we've established an open source project around this months ago. And we've already had some serious commits on that. So between the open spec, the work with SYCL, and the open source project, we're trying to do everything we can to give this a good head start in the industry and get others to adopt it. And then there's a set of libraries, and we didn't put libraries in here that are already well established and standardized, so you won't see MPI listed here. There's no need to re-offer that up in an open spec. But there are a variety of domains here, math, obviously critical in HPC, threading based on our threading building blocks that a lot of people have adopted, DPC++ library, which is really kind of a combination of parallel STL from C++ and some boost.compute functions that we think are valuable for kernel-based programming. Analytics and ML really focused on classic machine learning and statistical analysis. And then you've got a DNN and a machine learning communications library used primarily just by developers of deep learning frameworks. So for DNN for single node optimization, and then the machine learning communications for distributed compute across a cluster, distributed training jobs particularly. And then a video processing library for optimized codecs and other video processing functions. So these are all part of the open oneAPI specification. That's all out there on oneAPI.com now, and we encourage you to take a look at that spec and give us some feedback on that. In terms of support for this industry initiative, we have a lot of companies that have chimed in on this. No one wants n different programming languages for n different architectures, or n times m architectures times vendors, right? So I'll point out one of these in particular, CodePlay, who's been really active in the SYCL efforts before. They announced yesterday they're going to put out a data parallel C++ to NVIDIA compiler. So that'll be a good path to get to NVIDIA GPUs with data parallel C++. Now let's switch gears just a little bit and talk about Intel's implementation of the oneAPI spec. And we released beta products around these. So in addition to the compilers and libraries, implementations of those, we add a couple things for our tools. One of them is what we call the DPC++ compatibility tool. And what that is a migration assistant to help bring CUDA code into data parallel C++. It's a source-to-source migration tool. It's not 100%. It does require developer intervention to finish the last 10 or 20% of the code. But the goal is to just automate a lot of the drudgery of language conversion. And then in addition to the DPC++ compatibility tool, we're enhancing some of our analysis tools that we've had in market for a long time. The vTune profiler is being enhanced, so now we can look at combined CPU accelerator systems, including memory, threading, etc. And then the Intel Advisor tool, which people use today to look for better opportunities for threading and vectorization, we're adding an offload advisor capability. And what that does is, knowing specifications of given GPUs, like the Ponte Vecchio GPU we announced, it's part of the Aurora exascale computer. It'll let you do things like it'll run across your code, find things like tight inner loops that you would benefit and get the most profit from offloading to the GPU, and tell you how much performance you get from that and how that outweighs any data movement overhead. Question?
How difficult is the migration?
Pardon?
How difficult is the migration?
Well, it'll automate about 80 or 90% of the code migration. So the rest of that, what we do is we put inline comments in the code to give you a hint about what you need to do to complete it. It's mainly just due to architectural differences and things we can't automatically bridge between the two languages. So it depends on the size of your code, how difficult it is, but it is about 10 to 20% of the effort you'd have to do by hand. And then just quickly, the way we're delivering these in the form of toolkits, there'll be a base toolkit that includes all of those tools I mentioned. Plus, for certain individual domains like HPC, Fortran, OpenMP, and MPI are included in this oneAPI HPC add-on toolkit. And then similarly for some other domains, add-on capabilities that we didn't decide to put in the base toolkit for everyone. I'll ignore these for now mainly, but just kind of related toolkits that aren't properly part of oneAPI, but for inference, in particular OpenVINO, AI analytics is optimized frameworks to run on Intel architecture and our optimized Python distribution. And then I'll just wrap up and say that we have this dev cloud available. You can get the beta and just download it, use it however you want. But if you want an easy way with no downloads, no hardware installs to get access to CPUs, GPUs, and FPGAs in the cloud, we encourage you, this is all free. You can log in, get your own sandbox, and try it out, and give us some feedback. And so, yeah, just go to Intel oneAPI and check it out. And yeah, let me know if you have any more questions. All right, thanks for coming. Oh, go ahead. Yeah.
Is it free, the dev pod?
Say that, what
the
was
dev
that?
pod is free or?
It's 100% free. Yeah, the beta and the dev cloud are free to use. Yeah. All right, well, thanks, everybody. Appreciate it.
All right, that was a quick presentation. That's the kind we like. Thanks a lot for coming to our booth.